In these problems, we're going to be using L'Hopital's rule again to evaluate limits. These problems are different than the last ones that we did because they are limits as x approaches infinity, or limits at infinity. Still, we need to make sure it's in one of the indeterminate forms before we apply L'Hopital's rule. So the last problems were all the limit as x approach some value a, and in these we're going to apply L'Hopital's with the limit as x approaches infinity. And so the first thing we have to do is recall sort of our knowledge of what happens when we take limits as x approaches infinity. And remember, when we're doing this, we're only really concerned about the largest powered terms in the numerator and the denominator, because the other ones sort of get overpowered. So if I were to take the limit as x approaches infinity, the top would go to infinity and the bottom would go to negative infinity, wouldn't it? So that is going to be in the indeterminate form. Remember, if it's in any form, 0 over 0, or positive or negative infinity over positive or negative infinity. So this is the indeterminate form, and we can use L'Hopital's. So L'Hopital says, okay, you can take the derivative of the top and take the derivative of the bottom and then retake the limit. So let's do that. The derivative of the top is 8x minus 5 all over negative 6x. Again, if I look at my limit as x approaches infinity, I'm still going to be positive infinity over negative infinity. So again, we can use L'Hopital's. And we get the limit as x approaches infinity of 8 over negative 6. And now we can take the limit as x approaches infinity of a constant function. Remember, a constant function, it doesn't matter what you're taking the limit at. It's always going to be that constant. So we have it's equal to 8 over negative 6, which is also equal to 4 over negative 3. And let's think about what this means. Remember, when we're looking at the limit as x approaches infinity, we can find the horizontal asymptotes that way, can't we? We look at what's happening way out on the far ends to find our horizontal asymptote. And we see that y equals 4 over negative 3 is going to be a horizontal asymptote on this function. All right, so let's look at the second one. If I take the limit as x approaches of infinity of x over e to the x, that's going to be infinity over infinity. So we can use L'Hopital's, can't we? So I get the limit as x approaches infinity of 1. The derivative of x is just 1, and the derivative of e to the x is just e to the x. And now let's look at the limit as x approaches infinity of this function. So the numerator is going to stay 1, and the denominator, as x goes to infinity, e to the x goes to infinity. So we're looking at 1 over infinity, or 1 over a very large number. As we get infinitely large in the denominator, our fraction is going to get smaller and smaller, isn't it? And it's going to go to 0. So that is my limit. And again, trying to apply this and see how this helps us in life, we can see then that y equals 0 is going to be a horizontal asymptote. Okay? And then the final problem is the limit as x approaches infinity of x squared over e to the x. And if I look at this problem, I get, and take the limit, I'm going to go infinity over infinity as well. So let's apply L'Hopital's. And I get the limit as x approaches infinity of 2x over e to the x. Again, I try to take the limit, and I'm going to get infinity over infinity. So let's use L'Hopital's again. And I get the limit as x approaches infinity of 2 over e to the x. And when I take the limit again, I'm going to get 2 over a very, very large number again, and so that's going to be approaching 0, isn't it? So just to recap, L'Hopital's really only just gives us another tool for taking the limit of certain functions. And this piece up here about y equals 4 over negative 3 being the horizontal asymptote. That is something that we did in a previous lesson, and we were able to do it previously. I was just showing you how this tool, new tool, helps us to do this in maybe a more efficient way.